Today we will learn about the design of spur gear. Earlier in our session we have discussed about the introduction of gear and their classification and their different type of gears, and we also discussed about the terminology of gear. So I think you will understand all the concepts of introduction of gear. So today we will start designing of spur gear. So in a very simple way I will teach you the design of spur gear, and after this session you may solve the numerical problems on spur gear. So dear students, as we already know that spur gear is a gear that have straight tooth or the tooth parallel to the axis of rotation of shaft. And I already show you the diagram for the spur gear. That means spur gear is those gears which have teeth. The teeth on the gear is straight, and that is with the parallel to the axis of the shaft. Okay. So we can design a spur gear with the help of few steps. There are few steps by step. If we solve the numerical problem, then we may design any spur gear. So students, in this session I don't tell you about the formulas which are using in the spur gear, but because you already have your data design book with you and you have the textbook with you, so I only tell you about the steps used in designing of spur gear. So students, we have two to three types of problems for solving spur gear, or numerical problem for designing spur gear. So one type of problem have given only the few dimensions, and you have to find out, or you have to design the spur gear against these dimensions. So in that type you have to assume, or you have to take the assumptions from the data design book about the few values of the gear or about the spur gear. And in the other numerical problem we have given the data of which we have required, and many things we have to assume from the data design book, or many things we have to take from the tables of data design book. So when we design a spur gear, in designing a spur gear, the step one is to first find the number of teeth for gear and pinion. So first of all we have to find out the number of teeth for gear as well as pinion. As you already know that velocity ratio for gears may be find out by the gear, okay, or driver. We can say that a number of teeth on follower divided by number of teeth on driver. Okay, from here we can get the velocity ratio and we can find out the teeth on driver. Okay, from here we can get the velocity ratio and we can find out the number of teeth on gear. Okay, we have the diameter of the follower divided by diameter of the driver. The speed is opposite to the teeth and diameter. There speed of the driver is upside and speed of the follower is downside for velocity ratio. Means what? Velocity ratio is equal to speed of the driver divided by speed of the follower in RPMs. Okay, this is our first step in designing the spur gear. In the next step, we have to find out the velocity ratio. As we have discussed in step number 1 about the velocity ratio, if the velocity ratio is given, we may find the teeth on the gear. If velocity ratio is not given, we may find the velocity ratio with the help of teeth on the gears. So something relation is given about the teeth and the velocity ratio. If not given, we have to assume the number of teeth on pinion first. If the number of teeth on pinion is not given, number of teeth on gear is not given, we have to assume the number of teeth on pinion first. Okay, and it may be assumed from the data design book, or it may be taken as 18. TP is taken at it as 18 if the value of the teeth for both gear and pinion is not given, we may take the value as TP is equal to 18 if we don't have any values for finding the number of teeth. Then we take, if we have the values for finding the teeth, then we don't take these values. Step number 3, find the Lewis form factor for the pinion and gear. Students, in step number 3, we have to find out the Lewis form factor, and it is denoted by Y, capital Y, or in some book it may be denoted by small y, and in different book maybe notation may be different for different books. So Lewis form factor is taken from the Lewis equation. It may be taken from the Lewis equations, and it have a different formula for different degree, different pressure degree angles, or it may be for there are 3 to 4 conditions for Lewis factor. One is for 14:1/2 full depth involute gear. Similarly for 20-degree full depth involute gears and 20-degree stub gear. So these are the conditions for Lewis form factor, and we have take the formula according to the given conditions in the statement of about the spur gear. Okay, so after finding the value of Lewis form factor for pinion and gear, if the gear and pinion are made of same material, we can say that if gear and pinion are made of steel, then we don't find the wicker between the pinion and gear. That means in the smaller portion, that means smaller gear is the wicker section. So pinion have smaller in size as compared to gear. So if the pinion and gear are made of same material, then always pinion has the wicker member. But if the gear and the pinion made of different materials, then we have to find out the Lewis form factor for both, for pinion as well as for gear, and we have to find out the value which one is bigger and which one is smaller. Okay, so from finding the value of YP, Lewis form factor for pinion, and Lewis form factor for gear, and which value is greater, that one is the strong member, and which value is lesser, that one is the weaker member. So we have to design the spur gear for weaker member, not for strong member. If the value of pinion is small than the value of gear, then we have to design the spur gear for pinion only. Okay, and if the value of the Lewis form factor for gear is smaller than pinion, then we have to design for the spur gear for gear only. Okay, I think students, you may get the points of how we can calculate the Lewis form factor. I again told you that the formulas are written in your textbooks as well as your data design book. You may prefer the formula from them. Okay, so because due to limitations of writing formula in the software or in PowerPoints, I don't write it on presentation. So you may get from the data design book. Okay. So step number 5, material selection from table. If the material is not mentioned about the gear is made of which material, then we have to select material from the data design book, or there is a table also provided. So from there we have to select a material for a suitable material for the gear, and then we have to take the value of pinion with highest strength. We have to take the value of pinion with highest strength from data design book. So you have to note that point, that we have take the value of pinion with highest strength from data design book if the material is not mentioned about the gear and pinion. Okay. Step number 6, design for wicker section. As already told you about in step number 4 or 5, that we have to design for wicker section. From Lewis form factor, we know about the wicker member, which one is wicker member. Then we have to design for the wicker member. Okay, then we have to start procedure for designing that member, because the wicker member may fails during the power transmission, so we have to redesign that member because it have the lesser value. Okay, So step number 7, and step number 7, we have to design of gear based on bending. We can design the gear on two bases, on two types. First one is design of, second one is design of gear based on contact stress. I in the recent session we already discussed about the bending stress and the contact stress in the previous lecture. I will in previous lecture we have seen a diagram on that we have used is a finite element analysis, and there is a red spots in that diagram. That red spots showing you the bending stresses and the contact stresses on the gear. So we can design, we have to remove these bending stress and contact stresses as much as we can. Okay. So for design of gear based on bending, we have to find out the module first. Okay. And for design of gear based on contact stresses, we have to find out the dynamic load, that is WD. We have to find out the wear load. We have to find out the static load. So for the safe design of spur gear, the dynamic load is always smaller than the wear load as well as static load. If the dynamic load is lesser than wear load and static load, then our design is safe. Okay. So we have the different formulas for finding out dynamic load. We have the formula of dynamic load finding. We have the formula for wear load finding. We have the formula for static load finding. So with the help of these three formulas, we can easily calculate these values of WD, WW and WS. And after comparing, we can easily told about the safe design and the not safe design. So students, from here we have 7 steps for designing a spur gear. Now I will show you few problems about the spur gear. So on the basis of those, you may force. So in force analysis of any type of gear, we have to find out these radial force, tangential force and normal force. Okay. So as you already know, or we already discussed about the power transmitted by the gear, we have to first find out these forces. Okay. We have to find out these forces, and how we can find out these forces. We can easily find out these forces by resolving these forces about any horizontal direction and about any vertical direction. In the given problem, we have know about the angle between them, or we have known about any one of the force. Then we can easily find out the tangential force or radial force or normal force. Okay. So PT, as you know that PT is tangential force, or it obtained from power. PT, we can say that it may be a tangential load acting on the top of the gear. P is power. Okay. And power, you know that the formula 2 pi nt divided by 60. And from here we can easily find out the torque, or if the torque is given, we can easily find out the power. Okay. So if we have to find out torque and the tangential load or load on the tooth is given, okay, then we can easily, tangential force is given, we can easily find out the torque. That formula for torque finding, if the tangential force is given, is tangential force multiplied by the radius of that gear. Okay. Similarly, if we have to find out tangential force and torque is given, then we can easily find out the tangential force. And the formula for tangential force is 2t divided by d, or we can say that t divided by r, radius of the gear. Okay. So, and how we can find out the value of PR, PT, as we already know, PR is radial force on the tooth of the gear, PT is tangential force, and tangent alpha is the angle between the normal and the tangential force. So alpha, from here we can easily find out these values, and cos alpha, these values, cos alpha tangent alpha is taken from the above diagrams. Tangent is equal to, you know that tangents equal to what? Tangent is equal to perpendicular divided by base. Okay. Similarly, cos is equal to what? Base upon hypotenuse. Okay, so from here we can easily find out these values if we have known the angle. Okay, so this is design procedure for spur gear, and I already told you that I don't discuss about the formulas which are using in the numerical problem, because you have your data design book as well as your textbooks. So you may find these formulas from your data design book, which one you have. You can prefer any of the book which you have. You may prefer VB Bandari, you may prefer RS Khurmi, or you may prefer any other book. Okay, so students, we have now take a numerical problem. Okay, so this is our first numerical problem of first type. In this numerical problem, a spur gear transmit 15 kilowatt power. Power is given, transmitted by the gear, and rotating at 144 rpm, and other gear rotates at 576 rpm. Then design a spur gear. We have to design a spur gear, and we have only three values, that is N1, N2 and P, that is power transmitted. And we have take a few assumptions because we have only few dimensions, so we assume many things in this numerical. We have to assume that the gear and the pinion made of same material. So we have find only the Lewis form factor for pinion only, don't find the value of Lewis form factor for gear. So in the step number 1, we have to find out first the teeth, as we already discussed about that we have to find out first the teeth on the pinion. Okay, and what is the formula for finding teeth of the pinion is 2f naught divided by sine square alpha, and this formula is mentioned in your data design book. You may find easily. Okay, f naught is for one for full depth 20 degree. Okay, full depth 20 degree involute tooth. Okay, we assume that the gear is of 20 degree pressure angle of full depth involute gear. Okay, and f naught is here height factor. Okay, so alpha is pressure angle, so we have already assumed that alpha is 20 degree. Okay, this is assumptions, these are assumptions only, we assume these values, and after these assumptions we may find a TP is equal to 18. Okay, and we directly also take TP is equal to 18 if we don't have any value for finding a TP. Okay, teeth on pinion. And after that, after finding TP, we have to find out velocity ratio. And what is the formula for velocity ratio? The formula for velocity ratio is speed of the driver in pinion in RPM, speed of the follower. Okay, speed of driver is upside, speed of pinion speed of follower is downside. Okay, so 576 is for N2 and 144 for N1, and we may get the values of TG also, because we have already calculated the value of teeth on pinion, and with the help of teeth on pinion we can easily find out the teeth on gear, because velocity ratio is equal to TG by TP. That means what is the formula for velocity ratio? The formula for velocity ratio is teeth on the follower divided by teeth on the driver. Okay, so from here we get the value of TG is equal to 72. After that, in the next step we have to find out the Lewis form factor, that is step number 3. So we have to find out Lewis form factor for only one if we made the assumption is that the gear is made of same material. So we made assumptions for different material. If then we have to find out for both values. Okay, and if we made the assumption of same material, the gear is also made of steel and the pinion is also made of steel, then we have only find out the Lewis form factor for pinion only, because the pinion is the less or weaker section. And after that we have to, in step number 4, material selection, we have to assume or take material from the table about the pinion. Okay, material, we have to select material from the pinion, and from here we get the values of bending stress as well as crushing stress. Similarly, we get the value for bending stress as well as crushing stress if the materials for gear and pinion are different. Then we take the two different values. In step number 5, determination of weaker member. As we already know about the which one is weaker member after finding the Lewis form factor. Okay, after finding Lewis form factor, it is multiplied with the bending stresses. Okay, and by multiplying bending stresses, we get the value, and we can easily know about the which one is weaker section. And next step is design for the weaker section. In the next step, we have to design for weaker section. And after in the designing section, we have to find out the value of dynamic load, static load, wear load, and after in the end we have to check that the dynamic load is lesser from wear load as well as static load, and then our design is safe. Point about the solution of the numerical problems. So I also show you some steps about the formulas. You may get the ideas how we take the formulas. So design procedure of Spur gear is WT here is what is WT here? WT here is the tangential load on the tooth. That is tangential load on tooth of the gear. That is equal to power divided by velocity. Okay, and multiplied by service factor. So P is power, V is velocity, and CS is service factor, and the value of CS is taken from the data design book, which is in the any of the data design book. And value of V, that means value of velocity, is equal to pi dn upon 60. This may be different for gear as well as pinion. If the material for gear and pinion are different, we have to find out the value of V for two different values. Pi into dp into n. Dp is for diameter of pinion, and np is for speed of pinion. Similarly, we have pi dg ng divided by 60 for gear, and cs is service factor, and cv is velocity factor. So if we have given the tangential load, we may find power, and if the power is given, we may find tangential load. If all the values are not given, then we may find the tangential load with the help of other formula, and that formula is Wt is equal to sigma naught into Cv into B into pi into m into y. So here sigma naught is the stress on the gear tooth, Cv here is velocity factor, B is face width, pi is, you know, that is a constant value, m is module. And what is module? You know that module is in the terminology of gear, and module is equal to diameter of the gear divided by teeth on the gear. Okay, module is equal to diameter of the gear divided by teeth on the gear, and y is a Lewis form factor. Okay, so from here we can easily find out the value of Wt, or tangential tooth load, the value of tangential tooth load. Okay, so this is our first step, students, and in the end we have to find out the value of Wt. Okay, that means tangential tooth load, value of tangential tooth load. And you know that the B is denoted by face width, Y is for tooth form factor, and formula for Lewis form factor is different for different conditions. As you know that 0.124 minus 0.684 divided by t here is number of teeth on that gear, maybe teeth on pinion and teeth on gear also. If we have to find out for pinion, we have to take TP, and if we have to take find out for gear, then we have to take TG. And in the first condition, pressure angle is 14.5 composite full depth involute. We may take this formula. If the pressure angle is 20 degree for full depth involute system, then we take this formula. And the condition is for 20 degree stub involute system, then we take this formula. And after finding the value of Lewis factor, then we have to find out which one is the weaker section. And after finding the weaker section, then we have to design the gear, spur gear for the weaker section. Okay, then we have to find out static load, then we have to find the dynamic load. We have the formula for static load, we have the formula for this is the formula for static load. Okay, this one is the formula for static load, this one is the formula for dynamic load. Okay, and after that, in the end, we have to find out the formula for V.R load also. Okay, this is the formula for V.R load, and in the end we have to check which one is the if the value of WD is shorter than wear load as well as static load. So students, I think you may understand the concept of designing of spur gear. If you have any doubts or doubts regarding these numerical problems, you may comment in the video, and we may take more numerical problems, and we may give you the introduction or demo about how to check these values in data design book also. Okay, so till then, thank you. Meet you in your next session or next video with the new topic. Till then, bye. Thank you.